Hello everyone. In this video, we are going to understand about the secant method. So we will see what is the concept behind the secant method, and we will also see a working example to understand this method. And at last, we will see that how we can implement the secant method using a C program. So secant method is actually a method to find the roots of a algebraic as well as transcendental equation. And this method is similar to the regular falsi method. So if you have not seen my previous video on the regular falsi method, you can find the link of that video in the description box or in the I button also. So it will be useful for you if you watch that video, because this secant method is actually similar to that regular falsi method only. And if you have seen that regular falsi method video, then you will find very easy to understand this secant method. So let's start. So as I told you, secant method is a approximation method, or you can say numerical method, which help us to find the roots of the algebraic as well as transcendental equation. And this method is also known as Code method. So we will see why this is known as the Code method. So secant method works similar to the regular falsi method. But then the question is, what is the difference between these two methods? So these are the differences between the regular falsi method and the secant method. So if you see in the regular falsi method, we find the x1 and x2, that is the initial boundary between which we can find the roots based on these conditions. That is, we have to choose x1 and x2 such that f of x1 and f of x2 should be of opposite sign. But in secant method, there is no need of checking this condition. That is, x1 and x2 can be anything. We need not to check this condition of the opposite sign. Now the second difference is, the regular falsi method always converges. But in secant method, it is not guaranteed that it will always converge. It can diverge also in some cases. So what is the meaning of convergence? So if you just normally see in the English language, convergence can be shown in this way. For example, you are going via a road, and then road is just getting narrower and narrower. So you will say that this road is getting converged to this some point. On the other way, if you see this road, now this road is going this way. Now it is now getting wider and wider. So you will say now this road is diverging. So in the similar manner, what does it mean by that a method is getting converged or not converged? So you can see here this figure, we have taken initial boundary as x1 and x2, and this is our actual root. So now in the regular falsi method, this boundary will be getting converged, or it will be getting narrower and narrower. So our root, or you can say the approximate root, will always be between the x1 and x2 in each of the iteration. That means we will be getting closer and closer to our this actual root. That means in regular falsi method, we will always reach to a solution between the x1 and x2. But in the secant method, it can happen that in one of the iteration, our intermediate point will be between x1 and x2. But in the next iteration, it can happen that the root will not lie between the x1 and x2. It will, let's say, lie somewhere here. That is, it will not come between this x1 and x2. So we will say that our root is getting diverged from this actual root, or we can say we are getting away from our this interval. We are diverging from our this interval. So in some of the cases, secant method can diverge also. Now the third difference is, the regular falsi method is slower in comparison to secant method. Now what does it mean by slower and faster? For example, I have this equation, and I want to find the root of this equation using regular falsi as well as secant method. So let's say regular falsi method give me some value of root, let's say 2.34, and I get this value, let's say in 10th iteration. Now the secant method can give me this value, that is x equal to 2.34 in lesser iteration. That is, it can give me, let's say in the 6th iteration or in the 7th iteration, the same value that I was getting from the regular falsi method. So it shows that secant method can give me the same answer in lesser iteration in comparison to regular falsi method. But you have to take care that this thing is only true when secant method is converging. If secant method is not converging, that is, it is just diverging from the solution, then we can say that secant method is faster or slower. So I think you have understood the differences between the regular falsi and the secant method. So the most important thing is that regular falsi method, we have to check this condition, but in secant method, we need not to check this condition. And secant method can diverge also in some of the cases. Now let's see the algorithm for the secant method. So the algorithm is very much similar to the regular falsi method, but there are some differences. So let's see. So initially we have to take the initial boundaries in which we can find the roots. So let's say those points are x1 and x2. Now in regular falsi method, we were checking the condition, that is these x1 and x2 should be in such a way so that f of x1 and f of x2, they should be of opposite sign. But in secant method, we need not to check this condition. We can take any x1 and x2. Now in the second step, we have to find the intermediate point using this formula. And again, the formula is same as we have discussed in the regular falsi method. Now after second step, we have to come to the third step, and here we are changing the value of x1 and x2. So till second point, we have x1 and x2, and we have x also. In this case, here we are saying that x1 should be initialized with x2 and x2 should be initialized with x. So this means x1 should be getting the value of x2 and x2 should be getting the value of x. Now in regular falsi method, we were checking these conditions to change the value of x1 and x2. But in secant method, we need not to check these conditions. We can just shift the x1 and x2 in this way. x1 should be getting the value of x2 and x2 should be getting the value of x. And then we should be going to the step number 2. That is, again, we have to repeat this step. And again, we will find the x value between the new x1 and x2 that we got from this step. Now if I ask you what is the new value inside x1 and x2, so you can simply say that x2 and x, these are the new values which are getting actually used in the second step. That is, here x2 and x are getting used in place of x1 and in place of this x2. So again we will find the value of x, and again we will change the value of x1 and x2. So this second and third step will keep on repeating until we have reached to the maximum iteration or our absolute difference between the current root and the previous iteration root is less than absolute error, or you can say tolerance limit. And when any of the condition from the fourth step is like satisfied, then we will print finally the value of the root. That is, we will print the x. So here we can see what is the difference from the regular falsi method in case of secant method. Here in the first step, we need not to check this condition, and during shifting, we need not to check these conditions. So actually in the third step, we can say that at each iteration, two of the most recent approximate values of the root, they are getting used in the next approximation. So what does it mean? So let's say in the first iteration, we were having x1 and x2 initially. Then we found the value of x. Now in the third step, what we are doing? We are saying that x1 should go to the x2 and x2 should go to the x. That means x1 should be getting the value of x2 and x2 should be getting the value of x. That means in the second iteration, which values are getting used? x2 and x. Now in the second iteration, we will find the value of the x between this and this. So a new x will be found, right? And again, what we will be doing, we will be saying, okay, our new x1 and x2 will be the current value of x2 and current value of x. So it is like in the first step, this will be your x1 and this will be your x2. So in the second step or the second iteration, x1 is this, x2 is this, and new x is this. In the second iteration, this step will actually do this thing. x1 will come here and x2 will come here. That means now in the third iteration, x2, that means this value and this x value will be getting used. That means at every time, the last two values of the x that we are getting, they are actually used in the next iterations. So this concept is very much important to understand, because while making the program, we have to understand that how to x1 and x2 are getting shifted or changed. Now before moving to the working example for the secant method, let us understand the generalized formula for finding the value of x. Let's say we are at the iteration number 1 and this iteration is shown by n. So n equal to 1 means we are starting with the first iteration. So in the first iteration, we will find the value of x using this formula, x1 and x2, and we got the value of the root, that is first approximation of our root, as x3. Now after finding this x3, we have to change this x1 and x2. So here we are saying x1 should go to the x2 and x2 should take the value of this x3. So that means in this second iteration, our x2 and x3 will be getting used and x1 it will be getting discarded. So when we will come into the second iteration, that is n equal to 2, in the formula we will be actually putting the value of x2 and x3, which are actually our new x1 and x2 also. So here I have put the value of x2 and x3, and accordingly I have put the f of x3 and f of x2. And finally I got x4, that is my second approximate root. So here we have to notice that I am not putting this x1 and x2. The point is I am using x2 and x3 in my formula. That is, the last two values are getting used in the next iteration. So I have got x4 now. Now in the next iteration, what I will be using? I will be using x3 and x4 as my new boundaries. So here I have shifted x2 and x3. So we can simply say x3 and x4 are getting used in our next iteration. So in this n equal to 3, we are putting the value of x3 and x4 in our formula. And we have got new value of our approximate root, that is x5. So if I ask you what will be the value of my x in the nth iteration, so this will be our general formula for the nth iteration. So here you can see we have written x n plus 2, and here we have n plus 1 and so on. So if you see here, for n equal to 1, we are putting here x of 1 and here x of 2 and so on. But when n is equal to 2, we are saying x of 2 and then here x3, that means 2 plus 1, 3. And accordingly, if n equal to 3 is there, then this 3 is same as value of n, but this 4 is actually n plus 1, that is 3 plus 1. So in the same way, we have put the value of here xn, here it is xn plus 1, and here it is xn plus 1. Why? So if you see here, for n equal to 1, what we are putting here? x2, that is 1 plus 1. So here n plus 1 is there, and here it is xn, that means if n equal to 1, then here we are just putting x of 1, that is subscript will be similar as n. And same case is for the denominator. Now here we have written as for general nth iteration, we are saying we have to find the x n plus 2. Why? You can see here, when n is 1, then we are saying 3, that is 1 plus 2. The same way, when we are saying n equal to 2, then we are saying we are finding x4, that is n value is 2 plus 2, that is 4. The same way, this 5 will come as 3 plus 2. So again and again we are saying n plus 2. So we are saying add the 2 in the value of n. That's why we are saying x n plus 2. Now one last important concept to understand is, here if you see in this x3 formula, we have x1 and x2. But when we move to the next iteration, what we are saying? We are saying put x2, and here we are saying x3. That means here the subscript is 1, but here it will be 2. In the first iteration it is 2, but here it will be 3. The same way, in the first iteration here we have 2, but here it will be 2 plus 1. Here subscript is 1, but it will be 2 here, that is 1 plus 1. That is, whatever the subscript were present in the previous iteration, in the next iteration the subscript will be incremented by 1. The same thing you can see here also. Here we have 2 and 3, but here we have 3 and 4. That is, we are adding 1 to the previous iteration. So this concept we will be using in our working example. Now if you have seen my video on the regular falsi method, there I have shown you that how we can derive this formula, that is x equal to this thing. So just for a recall, whatever we were doing in the regular falsi method to derive this formula, we will be doing same thing here in secant method also. So what we were doing, we were taking the x1 and x2 on the x-axis, and this is my function. So we were saying that graphically what you have to do to find the x, you have to find this point, and correspondingly you have to find this point. And this point will be x1 comma f of x1, and this point will be x2 comma f of x2. So let's say this is B point and this is your A point. So what you were doing in the regular falsi method, you were joining A and B using a straight line. The same way you will be joining A and B in secant method also. And this line is actually known as secant or the code. That's why secant method is known as chord method, because we are drawing this straight line or the chord to find our x. Now again, this will be my new boundary. This will be your new boundary. This, and again you have to find this point, and you will be drawing the line between this point and this point. So you draw this line, and again you found a new x. So this way secant method will always be drawing the chord between the new boundaries point. Now to derive this relation, what we have done in the regular falsi method, we discussed that what will be the coordinate of this x point. You will say x comma 0, and let's say this is c. So there we have applied the concept of slope to derive this formula, and we can see here also that slope of CB will be actually equal to slope of AB. So that's why I have written same line here. And what will be the slope of CB and what will be the slope of AB? So these are the slope of CB and AB, and we have to find the value of x finally. So what we can do is we can just cross multiply, and we can solve this relation to find the value of x. So if you solve this, you will finally get the value of x this only. So you can just try and you can find the value of x. I'm not solving it again, as I have discussed the same thing in the regular falsi method. So finally we are done with the theory or the concept behind the secant method. Now let's take a working example to understand the secant method. So we are given this equation, and equation is x cube minus fx plus 1, and we have to find the root of this equation, and the interval that is given to us is 0, 1. That is, the initial x1 will be 0 and x2 will be 1. We have to find the root between this interval only, and we have to carry this process till 4 iteration. That is, whatever the value of our root or the x we will be getting in our 4th iteration, that will be the answer for the root for this given question. So let's apply our secant method on this given equation, and let's start with the first iteration. So n equal to 1 means we are starting with the first iteration. So first step was you have to find the x1 and x2, and it is already given in the question that x1 is 0 and x2 is 1. Now what was the second step? We have to find the value of x. That is our first approximation to find the root of this given question. So what is the formula for the x? So this was the formula, and here we can see we need x1 and x2 as well as f of x1 and f of x2. So in the first step only, what we can do is we can just write the value of f of x1 and f of x2. So f of x1 means f of 0. So if we put 0 in this given equation, we will be getting 1 as the answer. And if we put the next value, that is f of 1, we will be getting minus 3 as the answer. Now we have all the values, that is f of x1 is 1 and f of x2 is minus 3. Now we can put all these values. So as we did in the regular falsi method, we were saying you have to just multiply this with the this and this x2 with the f of x1, as we can see in this formula also. So if we put all these values, so let's put all these values in this formula. So after solving, we will be getting 1 by 4, and 1 by 4 is 0.25. So this is the value of the x. Now before moving to the second iteration, we have to decide what will be the new value of the x1 and x2. That is, what new values or new boundaries we will be using in our second iteration. So as we discussed, the x1 will be coming to the x2 and x2 will be coming to x. Now instead of saying x, I will be saying it as x3. I have x1, I have x2, so this will be your x3. So this will ease our computation in our next iteration or in the further iteration. So here I can say instead of x, I am saying it is x3. So what does this mean? This actually means that in the second iteration, I will be using x2 and x3 values. So let's move to our second iteration. And here I am using the value of x2 and x3. And the value of x2 in the first iteration was 1 and x3 is 0.25. So I will be saying x2 will be 1 and x3 will be 0.25. So you can say this is my first step. Now I will be moving to the second step, that is I will be finding the value of x. Now here you can see I have x2, I have x3. So what will be the new value of x? I will be saying use x4. So let's write the formula for the x4. So here again we can see that we need the value of f of x2 and f of x3. So here in this step only we have to write the value of f of x2 and f of x3. So at x2 equal to 1, what was the value of f of x2? So it was -3. And at 0.25, what is the value? So here we can see in the first iteration we have not found the value of the function at 0.25. So this was actually x3. So what we have to do in the previous iteration only, we have to find the 0.25. So if I put this value inside this equation, I will be getting 0.234375 as my function value at 0.25, and this will be actually negative value. So same thing I have written in the second iteration. Now put all these values in the second iteration to find the value of x4. And let's see what we are getting. So I will be getting 0.18644 as the value of x4. Now before moving to the third iteration, let's find the value of x4. That is, we have to put this value in the given equation. So after putting this value, I will be getting 0.07428 as the function value at this point. So now if I ask you what will be the new value of the boundaries for the third iteration, so what actually we will be doing, we will be changing the value of x2 and x3. So x2 will be moving to the x3 and then x3 will be moving to the x4. That means we will be using x3 and x4 values in our next step. That means out of these values, the last two values, they will be going into the third iteration. So we can see initially we had x1 and x2, then we find the x3, and in the second iteration we started with the x2 and x3. Now in the third iteration we will be starting with x3 and x4. That means last two values are getting used in the next iterations. So x3 is 0.25 and x4 is 0.18644. So I have written the same value in this third iteration. Now let's find the value of f of x3. So f of x3 is this negative value and f of x4 was this value. Now let's find the value of x5. Now if I put all these values in the formula, then I will be actually getting the answer as 0.20174 as the value of x5. So you can solve this and you can see that we will be getting the similar value as I have written here. Now we have to find the value of f of x5 so that this can be used in our fourth iteration. So if you put this value in your given equation, you will be getting 0.00048 as the value. So our third iteration is also over. So if you see here, we started with the x3 and x4 and we found x5. So what are the new boundary value that we will be using in the fourth iteration? So again you can see that we will be using x4 and x5. How? Because we will be saying x3 will be going to the x4 and x4 it will be moving to the x5. So simply we can say x4 and x5. These value will be using in the fourth iteration. So this is my x4 and this is my x5. So let's write this value in our fourth iteration. So in the fourth iteration, I have written both these values. Now let's write the value of f of x4 also and f of x5 also. So I have copied these values from the third iteration. Now next step is finding the value of x. So what will be the subscript that I will be putting here in case of fourth iteration? So it will be 4 plus 2, 6. So you can see here also we have x4 and x5. The next subscript will be x6. Now again you can put all these four values inside the formula for the secant method and you can find the value of x6. So I will directly write here the value of x6 and you can find yourself also. So the value that I will be getting, it will be something 0.2016. So if you solve, you will also be getting the similar value as I have got. So now as the question was saying that we have to find the roots till 4 iteration. So in our fourth iteration, this is the value of the x that we have got. So this is the root for our given equation. That is, this is our answer. So if the question would have said that you have to carry this process till the 5th iteration, so again what I can do is I can find the value of f of x6 and after that I will be moving with the value of x5 and x6 for the 5th iteration. So I think you have understood that how we have applied this secant method on a given equation. And in the whole process you have seen that we were not checking the condition of the opposite sign as we were checking in the bisection method and in the regular falsi method. Now in the same question, if the question would have asked that you have to find the root of the given equation till the 3 correct decimal places, then how you would have proceeded? So the question actually means that after these decimal places in any of the x, you have to see that 3 values after these decimal values are equal or not, that is they are matching or not. For example, in this question, these were the values of the x that we were getting in the 4 iteration. So this was the first value, second, third and fourth. So if you see here, this is my 1x and this is my another x. So after decimal, I am getting 2, 5 here, and here the 2 values are 1 and 8. So these values are actually not matching. Now again, if you see for this x4 and x5, so here the 3 digits are 186 after decimal, and here we have 201. So these again are not matching. So we will proceed again with this x6. Now we will be checking this 201 and this 201. That is in x5 and x6, the values or the digits after the decimal places, they are matching till 3 decimal places. That's why we will stop at this point. That is in the 4th iteration only we will be stopped, and we will be saying that our x6 is our final root. And in programming, you can just print x5 also, because 3 digits are matching for both the cases. But if the question would have asked that you have to match the 4 decimal values after this decimal point, that is you have to find the answer till 4 correct decimal places, then in that case, here we have 2017 and here we have 2016. Then we would have proceeded with the 7th iteration also, because these 4 digits are not matching with each other. I think you have understood that how we can apply the secant method on a given question and what are the various ways of asking the question. So now we are done with the question, and we have seen that how we can approach or how we can apply the secant method to find the roots of a given equation. So now it's time to see the pseudo code for the secant method. So here is our pseudo code for the secant method. So here first we have taken the input from the user. We will taking the value of x1 and x2 from the user, and here maximum number of iteration is also asked. That is the number of iteration for which you want to run this secant method. Now after that, we can just start with our iteration, and here we need not to check whether our x1 and x2 are valid or not. The thing that we were doing in the regular falsi method, there we were checking whether f of x1 and f of x2 are of opposite sign or not, to check the validity of x1 and x2. Now we start with our I equal to 1, that is first iteration. So here you can see we have used a do while loop, and while loop is running till I is less than equal to n. Now if you remember the code for the regular falsi method, the slight difference is there. So the slight difference is that here we are shifting the x1 and x2 using these values. But in the regular falsi method, we were checking the conditions something like f of x1 and f of x1 should be lesser than 0, and f of x into f of x2, it should be less than 0. If this is true, then we were moving x2 equal to x. Otherwise, we were changing x1 equal to x. But here in secant method, we are not checking these conditions. We are shifting just x1 equal to x2 and x2 equal to x. So first we got x1 and x2. Then we have to find the value of x. So we have x1, x2, and we have now got some value of x. After that, we have shifted x1 and x2. That is, x1 is moving to x2 and x2 is now moving to x. That is, I will be using these x2 and x in my further steps. Now here, this if condition is checking for the absolute error. So if you recall the regular falsi method also, we were finding the difference between the current iteration x and the previous iteration x. And if that is lesser than your threshold, or you can say tolerance value, then you were printing the value of the x as your root of the given equation and you were returning. The same thing we are doing here. So here you have to find another value of x. So here we have used these x1 and x2. So essentially we are using the value of x2 and x in this equation, and we again found the new value of x, right? So a new value of x we will be getting. And where is the old value of x? That is this x, because this x will be overriding this previous x. So you can see here this x is actually getting saved inside x2. So you have previous or the old x inside x2, the current x inside this x. That's why you are subtracting x minus x2, or you can say x2 minus x. So now if the difference is lesser than this threshold value, you are printing the x, and after that you are just returning. And if this condition is not true, we are just going to the I++, that is our next iteration. So we can come out of this do while loop due to two conditions. Either this condition is false, or if this condition is true. That is, either our maximum iteration are reached, or we can say when the difference is lesser than this absolute error or the threshold, then also we can come out of this do while loop. So now we will be moving to the next iteration. And before coming to the next iteration, we have said that we are using x2 and x for our next process. So we have used x2 and x here also. First, we have x1, x2, then we found the value of the x also from this thing. And after that, we just changed x1 and x2. So these become my new x1 and x2. We used here. And after that, we are moving here. And in process, I got new value of x. And this was my previous value of x1 and x2. And when I come here, so I will be using x2 and x. That is, I will be using these values x2 and these x for my new shifting or for my new further iterations. So again and again, we are using the newer x values. And finally, when we will come out of this do while loop, we will be saying print x as the root. So either I can find the root or print the root using this line or this line. And here you can print either x or you can just print x2 also. Both will be correct. So I think you have understood the pseudocode for the secant method. Now let's see the C program for this secant method. So this is the C program to implement the secant method. So here if you start from the main function, I have asked the user to enter the value of x1 and x2. After taking x1 and x2, I have taken the iteration value or the maximum iteration value inside the maximum iteration variable. So max iteration is telling me the number of maximum iteration for which we want to run this secant method. Now after that, I have find the value of the x, that is my root. So I have taken a function find x, which is taking two arguments x1 and x2. So here if you see, this is the find x function, and it is actually applying the same formula that we have discussed for the secant method. So here you can see we have find value at function. So this function is actually giving me the function value at various points. So if I ask that find value at x2, so here this is the function, and x point, it is giving me the function value after putting this x value into the given equation. So in return, I will get the value, and I will be putting this value at the various point in this given formula. Finally, I will be getting the value of the x from this find x function. And after that, inside this do while loop, the same code that we have discussed in the pseudocode, we have written the same thing. So here we are changing the x1 and x2, and here again we are finding the x, and here we are finding the difference. So here I have used the f absolute function. Why f? F means floating point. So here x minus x2 will be a floating value. So to find the absolute value of this difference, I have used the f absolute function. And what is this epsilon value? So this is the threshold, or you can say a tolerance value. So here I have mentioned it as 0.0001. That means I am checking for the 4 correct decimal places. And if you want to check for the 3 decimal places, then you can put it as 0.001. Instead of macro, you can just put the value in place of epsilon here also directly. And after this do while loop, I am printing the final value of the root as x. So I can get the final value here also, or you can print the final value here also. So at 2 places, I am getting the value of x. Now let's run this program and see the output. So here I have to enter x1 and x2. So let's put 0 and 1, the same value that we have used in our secant method process. And let's say I want to run this process till 7 iteration. So here you see that I am getting the final root at 0.2016, and the total iteration for which this process has run is 4. So here I have shown the various values of the root in the 3 iteration, and at the 4 iteration I got this value. So why it did not run for the 7th iteration, or you can say 5, 6 and 7 iteration? It is because this value, that is the final value, I am getting due to this if condition. Inside this if condition only, this if was true. Why? Because I am matching for the correct 3 decimal places. You can see here it is 0.001, and you can also see here in the 4th iteration our value is 0.201640, and in the 3rd iteration this is the value. So the 3 digits of both these roots are matching. So that's why I just stopped my process at the 4th iteration only. And if you would have asked that check for the 4 correct decimal places, so let's see what we will be getting then. So let's say I entered 0 and 1, and let's say 7 iterations. So then also I am getting the same answer. Why I am getting the same answer? So as I discussed in my previous videos, that what we are doing here, we are saying that although sometime it may happen that this previous value and the current value, they will not be exactly matching till 4 correct decimal places, but the difference between those 2 values of the root should be less than this epsilon value. Then also we can just stop and we can print the root here only. So this difference is actually the absolute difference, or you can say the minimum difference that we want between the various root. So that's why we just stop at the 4th iteration only. So I think you have now understood the C program for the secant method. Now before ending the video, I want to tell you that what is the scenario where the secant method can diverge from its solution. So here you can see the function fx, and I have shown this function graphically. So this is the x and this is the y-axis. Now there are 2 points x1 and x2 on the x-axis. So according to secant method, how you can find the x point between the x1 and x2? So for that you draw this and you find this point. So after that you draw this line and you find this point. Then the next process is you join these 2 points using a straight line. So I have given the name as A and B to these points, and I have joined using this red line. Now this point will be known as x. So this time this x is lying between this x1 and x2 interval. Now let's say again I want to repeat this process to find the x between the new points. So new points will be x1 will be moved to this x2 and x2 will be moved to this x. So this x2 and x1 are my new points. Now if I draw the line again, this is my new point and this is my old point. Now if I join these 2 points using a straight line again, I will get this point on the x-axis. So this is my new root. Now if you see, this was my interval, and this x point, that is the root of this equation, is getting out of this interval. That means your root or the solution is getting diverged from this interval, this x2 and x1. So for this function fx, my solution is getting diverged. So I think you have understood that how this function can diverge from its solution. And here this is actually this, not his. So from this example, you can also see that even if x1 and x2 are taken such that f of x1 and f of x2 are negative, then also this method can diverge from its solution. That's why this method does not take into account that property that f of x1 or f of x2 should be of opposite sign. So this was all about the secant method. If you have any comment, query or suggestion, please write down in the comment box. And if you want videos on some particular topic, you can tell me that into the comment box. You can also watch my videos on the C programming, interview question, lead code solution and some other topics also on my channel. So if you are new to my channel, please subscribe my channel and press the bell icon for further notification. See you in the next video. Till then, goodbye.